The rise of the long-necked giants did not begin with ambition or dominance, but with a problem so basic that it shaped everything that followed. Because feeding a body on land had become harder than moving one. Jurassic landscapes produced enormous amounts of plant matter, but little of it was rich, dense, or easily digested, forcing herbivores to choose between speed that demanded quality food and size that could tolerate scarcity. Leaves were tough, fibrous, and slow to replace, spread across forests that rewarded reach more than pursuit and volume more than precision. In this world, energy arrived cheaply but thinly, distributed widely rather than concentrated, making grazing inefficient and browsing inevitable. Small bodies burned fuel too quickly, losing more energy moving between feeding sites than they gained by eating, while larger bodies could afford inefficiency simply by carrying more capacity. Size turned low-quality calories into usable abundance, because fermentation favored volume, time, and patience over speed. Digestive systems expanded not to extract more energy per bite, but to extract energy longer, letting food remain inside bodies until it yielded everything it could. Heat retention improved with mass, reducing metabolic cost in climates that fluctuated daily even when seasons stayed stable. Bones thickened not just to support weight, but to store minerals that buffered long feeding gaps. The long neck emerged not as ornament or advantage in combat, but as an accounting solution, allowing animals to harvest wide feeding arcs without moving their massive bodies at all. Each step costs energy, disturbed ground, and required recovery, while each sweep of the neck gathered calories cheaply and repeatedly. Standing still became more efficient than walking, and slowness became an economy rather than a weakness. Lungs expanded into complex systems that recycled air continuously, extracting oxygen efficiently enough to support bodies that could not sprint but did not need to. Circulation favored endurance over intensity, delivering nutrients steadily rather than explosively. These animals were not built to react quickly, because reaction was expensive and rarely rewarded. They were built to persist, converting time into survival and patience into scale. Growth itself became a strategy, because reaching large size early reduced predation risk without requiring speed or aggression. Juveniles that survived long enough to grow gained safety automatically, protected not by teeth or claws, but by mass that few predators could challenge. Energy economics rewarded those who could wait, eat broadly, and move rarely. As bodies grew, landscapes adjusted, with vegetation pressured into patterns that favored regrowth over height and resilience over delicacy. The land fed the giants because it could, but only as long as the balance between growth and consumption held. This balance was never comfortable, only tolerable, resting on assumptions that energy would continue to arrive slowly, predictably, and in vast quantity. The age of long necks began not when dinosaurs chose to grow large, but when the land made smallness too expensive to sustain, and in solving the problem of feeding themselves, the giants unknowingly began to solve the land itself into a system that would one day struggle to keep up with the cost of their success. Once energy economics favored size, the problem shifted from finding calories to carrying them, because a body that large could only survive if every system inside it was designed to spend as little as possible while lasting as long as necessary. The sauropod body became a structure built for distance even when standing still, because distance was not measured only in travel but in the amount of landscape a single animal could harvest without relocating. The long neck was the most visible expression of this design, extending reach outward so the body could remain planted while the head gathered food across a wide arc like a slow-moving crane. By browsing in circles without moving its feet, a sauropod could strip a feeding zone efficiently, then shift only when the zone was exhausted, reducing steps to a minimum and turning motion into a last resort. The head stayed small not because intelligence was unnecessary, but because every pound at the end of the neck multiplied the cost of holding it up, making lightness an economic requirement. Teat were built less for chewing than for cropping, because chewing wasted time and energy when fermentation could do the work more cheaply inside the gut. Food moved inward quickly, traded from mouth to stomach without refinement, because the goal was not precision but volume. The neck itself was not a simple tube of bone, but a carefully engineered column, with vertebrae shaped to reduce weight and support motion without demanding constant muscular effort. Air sacs threaded through the body, hollowing bones and reducing mass while also supporting a respiratory system that kept oxygen moving continuously. Breathing became efficient not by drawing air in and out the way mammals do, but by flowing it through, maintaining gas exchange even when the animal was not exerting itself. This constant flow mattered because size demanded stability, and stability depended on preventing internal systems from being stressed by sudden effort. The torso expanded into a fermentation chamber large enough to process low-quality plant matter slowly, producing energy steadily rather than in bursts. This slow release matched the animal's pace, creating a body whose metabolism did not spike and crash but stayed consistent like the climate it depended on. The limbs became columns rather than springs, built to support mass with minimal bending, because bending required muscle and muscle demanded fuel. Feet spread weight across wide surfaces, reducing sinking and protecting joints from the land's refusal to carry them kindly. Movement became a controlled fall forward, each step transferring weight carefully to avoid injury, because an injury to a giant was not a setback but a sentence. Speed offered no advantage when turning quickly risked breaking what could not be repaired as ollie. Slowness therefore became a form of protection, preserving structures that had taken years to build. The tail extended behind not merely as balance, but as counterweight, stabilizing the long neck by distributing mass along the body's length. The whole animal became a lever system, with weight allocated across distance and no single point carried too much at once. Even the skin and outer tissues reflected this economy, built to retain heat and reduce water loss. Because a giant that must drink often becomes a giant that must move often. Everything about the sauropod body pushed against unnecessary motion, because motion multiplied cost. Yet this same design allowed long-range travel when travel became unavoidable, because a body built for efficiency could endure distances that would exhaust smaller animals forced to burn energy rapidly. When a sauropod finally moved across the landscape, it did so not as a sprinting creature crossing territory, but as a slow machine converting stored energy into steady progress. Its gait was not dramatic, but relentless, capable of continuing for hours and days because it was not fueled by urgency but by endurance. This is why the age of long necks did not produce fast giants, because fast giants would have been too expensive to feed and too fragile to sustain. It produced slow giants whose bodies were built like walking economies, trading speed for reach, trading chewing for fermentation, trading muscle for structure, and trading quick survival for long, heavy continuity. A body built to stand still, efficiently still, cannot eat the same leaves forever. And so the age of long necks inevitably became an age of movement, not because sauropods wanted to roam, but because their scale turned landscapes into temporary allowances. A single herd could convert a green corridor into a stripped one with quiet speed. Because harvesting without chewing meant intake could be continuous, and continuous intake meant continuous pressure. Plants could recover, but recovery required time, and time belonged to places that were not being eaten. This created a simple logic that no animal needed to articulate, because it was felt in the thinning of brows and the widening distances between bites. When the feeding arc around a body stopped paying for itself, the only solution was to shift the entire body. And shifting a body like that became an event that shaped everything around it. Migration was therefore not seasonal romance, but accounting. A movement forced by depletion and limited by the rate at which the land could replace what was taken. The giants did not defend territories as predators might, because defending required speed, confrontation, and repeated patrol, all of which wasted energy and risked injury. Instead, they occupied corridors temporarily, moving through them like slow storms, leaving behind altered vegetation and ground that would not look the same again for years. Their routes followed water first, because water determined where plants grew thickly enough to justify the cost of stopping, and where bodies could replenish without traveling farther than the day allowed. Rivers became guidance, not as lines on a map, but as guarantees of renewal, drawing herds along predictable paths that repeated across generations. Floodplains offered the richest returns, but they also concentrated herds, increasing pressure until movement became mandatory. Droughts turned migration from routine into emergency, compressing animals into fewer viable corridors and forcing longer treks between feeding zones. In wet years, movement could be gentle and incremental, but in dry years, it became a test of whether size still paid for itself. The land itself began to respond to these migrations, with plant communities shifting toward resilience, favoring regrowth and toughness over height and delicacy. Areas repeatedly browsed became landscapes of low recovery, while areas spared became refuges that would later be targeted again, creating patterns of pressure that shaped regional ecology. The giants moved slowly, but their impact moved quickly through the system, because trampling and browsing altered soil, seed dispersal, and water infiltration in ways that lasted longer than the animal's presence. Feet compacted ground, reducing the ability of roots to breathe, while stripped foliage exposed soil to sun and wind that dried it faster. Paths widened into corridors, because repeating the same safe route cost less than scouting new ones, and cost was always the hidden ruler of sauropod behavior. These corridors became predictable not because the giants were unimaginative, but because predictability reduced risk, and risk was unacceptable at their scale. Predators learnt these routes, not to challenge adults, but to shadow the edges where juveniles lagged, and exhaustion created vulnerability. This pressure reinforced herd cohesion, because separation increased risk and cohesion reduced it without demanding speed. Young grew within moving communities, learning routes through repetition, imprinting landscapes into memory not as names or boundaries, but as sequences of water, vegetation, and safe ground. Migration became culture without needing language, a shared behavior preserved because it worked. The giants did not conquer new lands. They rotated through them, relying on the land's ability to heal between visits. This rotation was the only way to sustain bodies that large without collapsing the very food systems they depended on. Yet the larger the herds became, and the more routes overlapped, the more the land's recovery margin narrowed. What had once been a sustainable rhythm began to press closer to its limits. Because gigantism multiplied demand faster than landscapes could always respond. The age of long necks therefore carried an unavoidable tension, because success required movement, and movement required trust that somewhere ahead the land would still have something left to give. Where sauropods passed, the land did not collapse immediately, because ecosystems rarely admit failure all at once. But the pressure they applied accumulated quietly until even recovery began to feel like work. Trampling was the first form of damage that did not require hunger, because simply existing at that scale reshaped ground with every step. Soil compacted beneath repeated crossings, reducing pore space that roots depended on and turning once absorbent earth into surfaces that shed water rather than holding it. During heavy rains, runoff increased, carving channels where none had existed, while during dry periods the same compacted ground hardened into crust that resisted new growth. Vegetation suffered not only from being eaten, but from being disturbed, crushed, and uprooted in ways that removed future plant matter before it could be consumed. Young trees and cycads, slow to replace and vulnerable to breakage, became scarce in corridors repeatedly used, shifting the structure of forests toward what could survive pressure rather than what could grow tallest. Browse lines formed gradually, raising the minimum height at which foliage could persist and forcing plants into growth strategies that favored toughness and regrowth over density. Even when herds moved on, the land did not reset instantly, because recovery required stable conditions that were not always granted. In wet years, regrowth could be fast enough to appear effortless, but in average years it lagged, and in drought years it stalled entirely, turning temporary depletion into lasting scarcity. This created a feedback loop where herds returned sooner than the landscape could fully heal, not from choice, but because viable corridors narrowed elsewhere. Nutrient cycling changed as well, because massive quantities of dung redistributed fertility unevenly, enriching some patches while leaving others depleted, creating mosaics of growth and exhaustion. Scavengers and insects thrived on this abundance, accelerating decomposition and altering local food webs in ways that further concentrated activity along herd routes. Water sources degraded under repeated use, with banks collapsing, sediment increasing, and shallow areas turning muddy enough to reduce access, forcing animals to travel farther for reliable drinking. This additional travel increased trampling pressure elsewhere, spreading impact outward like ripples. The sheer demand for leaves altered forest composition over time, favoring fast-growing species that could tolerate browsing and reducing slow-growing forms that once shaped canopy structure. As canopy shifted, microclimates shifted, changing understory, humidity, and light, which in turn changed which plants could persist. The land responded to the giants by becoming a different land, molded by repeated pressure into ecosystems designed around disturbance. This disturbance was not catastrophic when balanced, because many systems can endure repeated stress if given enough time to recover. The danger emerged when pressures synchronized with climate stress, because then recovery windows narrowed and disturbances stacked instead of spacing themselves out. A dry year after a heavy browsing year did not merely slow regrowth, It erased it. A flood, after repeated trampling, did not merely reshape paths, it tore soil away. The giants could survive individual bad seasons because their bodies stored enough capacity. But landscapes could not store recovery the same way. The land required time, and time was the one resource herds consumed indirectly whenever they returned too soon. As pressure accumulated, herds became more dependent on larger ranges, because local areas could no longer support long stops. This expanded migration distances, increasing energy cost and raising the stakes of reaching the next viable corridor. Juvenile survival fell when travel increased. Because young bodies could not endure distance as efficiently and could not recover as quickly after scarcity. Predators benefited from this vulnerability, increasing pressure at the margins and forcing herds to stay cohesive even when food was patchier. The giants began to carry the land's strain within their own behavior, moving more often, staying less, and relying more heavily on predictable routes that now suffered most. This was the moment where gigantism began to approach its limits. Not because a single event threatened it, but because the land's ability to forgive repeated pressure was not infinite. The age of longnecks did not break the land instantly, but it pushed it toward a constant state of partial recovery, where ecosystems lived forever in the process of healing. And a world always healing is a world always vulnerable, because it has no margin left when the next stress arrives. For a long time, gigantism paid for itself because the land could still afford the bargain. But eventually the equation tightened, and the advantage of size began to depend on conditions so specific that it could no longer be taken for granted. Sauropods succeeded when vegetation was abundant enough to feed them without constant travel, when water was predictable enough to keep corridors green, and when recovery time existed between visits, allowing landscapes to regenerate before pressure returned. As climate variability increased across years and decades, that recovery time became less reliable, not because plants forgot how to grow, but because the windows that allowed growth narrowed. A few consecutive dry seasons did more than reduce leaves. They reduced the land's capacity to rebound afterward, forcing herds to travel farther even when their bodies were built to avoid travel whenever possible. This increased travel turned efficiency into expenditure, because every additional mile demanded energy, water, and time, and those demands fell unevenly on juveniles, the old, and the injured. When movement became frequent, the long neck's advantage weakened, because the body still paid its greatest cost in locomotion and ground impact, not in feeding. The system narrowed silently, with fewer viable corridors supporting larger bodies, and fewer safe margins, allowing herd size to remain high. Where once a herd could split and regroup across wide spaces, patchier vegetation forced concentration, keeping animals together longer and increasing pressure on the same ground. Concentration made predation more predictable and drought more dangerous. Because water sources became crowded, degraded, and increasingly contested by other herbivores. Competition intensified without ever becoming visible as conflict, because even without fighting, consuming the same limited browse created scarcity that no animal could negotiate away. Smaller herbivores adapted more easily because they could survive on less and move faster, while giants remained committed to a strategy that required the world to remain generous. This did not mean sauropods immediately declined, because their scale also granted resilience, allowing them to survive bad years by enduring rather than adapting. But endurance is not the same as sustainability, and over long stretches of time, endurance can hide decline. Reproduction became the fragile point, because adult giants could outlast scarcity, while young could not, and a population that loses juveniles does not collapse at once, it simply stops renewing itself. Nesting success depended on stable seasons and safe ground, and both became harder to guarantee as landscape stayed perpetually disturbed and climate oscillated more sharply. Ags required time, and time was the very margin the system was losing. The balance at the edge showed itself in subtle shifts, in fewer juveniles seen near feeding corridors, in longer gaps between herd movements, in greater reliance on particular river systems that could not support unlimited pressure indefinitely. Predators did not need to become stronger, because vulnerability increased naturally as travel distances rose and recovery periods shortened. Even a perfectly adapted giant becomes vulnerable when the world forces it to move more than its strategy was designed to tolerate. This is how size stops paying for itself, not through sudden failure, but through the slow tightening of conditions until the strategy becomes dependent on luck. The giants could still dominate when conditions aligned, but dominance is not stability. and the land was no longer stable enough to keep aligning for everyone. And the age of long necks approached a threshold where it could continue only if the world remained generous. And the world, shaped by tectonics climate, the giants themselves, was becoming less willing to maintain that generosity indefinitely. Near collapse did not arrive as a single season of silence, because the land rarely fails in one dramatic moment. But the strain reached a point where one more stress could tip systems that had been living too long without margin. Droughts became the most dangerous force not because they were new, but because they arrived into landscapes already committed to recovery, where plant communities had less stored resilience and soils held less water than they once had. When rainfall failed, browse thinned quickly, and what remained shifted toward tougher, less nutritious growth that demanded more intake for the same return. Sauropods could endure low quality, but they could not endure absence, and drought transformed abundance into distance. Water sources shrank, concentrating herds along fewer rivers and ponds, and concentration turned those places into bottlenecks where trampling damaged banks, increased sediment, and reduced access further. As access declined, herds were forced to spread outward from water, stripping vegetation in widening rings that pushed pressure into areas that might otherwise have recovered. This widened travel corridors, increased daily movement, and raised energy costs exactly when energy was hardest to obtain. Juveniles fell behind first, not from weakness alone, but because their smaller bodies could not browse as widely and could not store as much reserve against long gaps between good feeding zones. Predators did not need to attack adults to shape outcomes, because taking the young and the exhausted was enough to turn a difficult season into a demographic wound. Even without heavy predation, mortality increased through injury, because dry ground hardened into surfaces that punished joints and hooves, and every slip or misstep for a giant carried the risk of damage that could not heal quickly. A broken limb in a small animal might be survived through hiding and reduced movement, but for a sauropod it threatened starvation, because feeding still required reaching, shifting, and traveling to water. As injuries accumulated, herd speed slowed, and slower movement increased time spent in depleted areas, compounding scarcity. The land stress showed in the vegetation itself, in browse lines rising and regrowth failing to keep pace, turning familiar corridors into stretches of low return. When herds arrived at a corridor too early, they did not find recovery. They found the memory of their own previous passage, and the landscape offered less each time. This is how near collapse forms, not when a system stops working, but when it continues working at diminishing returns until any disruption becomes a threat. Floods could be as dangerous as droughts because degraded soils absorbed less water, creating runoff that tore away the thin layer of recovery and left behind ground that supported less growth afterward. Storms damaged already stressed forests, snapping young trees and washing away seeds, limiting future browse that could not be replaced quickly. As these stresses alternated, the land entered a cycle of partial rebuilding that never completed, and incomplete rebuilding became the new normal. Herd behavior shifted in response, becoming more conservative, staying closer to water, relying on narrower corridors, and accepting low-quality feeding rather than risking distance. But conservatism increased local pressure, and increased local pressure reduced recovery further, tightening the loop again. At the edge of this loop, a landscape can support giants only intermittently, allowing them to persist in favorable years, while undermining them across unfavorable sequences. This creates the illusion that dominance remains, even as the system beneath it becomes fragile. Near collapse therefore did not mean that giants vanished from sight, but that their presence became dependent on long stretches of luck, where the land had to provide more consistently than it was now capable of providing. The age of long necks approached a precarious state where the land could still feed them, but only if nothing went wrong, and the world never promised that. The legacy of the long necks is not simply that they existed, but that for a time the land consented to their scale. That consent demanded a price paid slowly by soil, vegetation, and the margins that make ecosystems resilient. Sauropods did not destroy the world they lived in, because destruction implies intent and suddenness, but their strategy reshaped landscapes into systems built around disturbance, recovery, and repeated pressure. Where they moved, ground became structured by corridors, compacted by weight, and altered by the constant trade between consumption and regrowth. Plant communities adapted toward toughness, speed of replacement, and the ability to survive being stripped repeatedly. reducing the prevalence of slower-growing forms that once stabilized canopy and soil. This change increased resilience to browsing but reduced richness, because a world dominated by recovery species becomes less varied, more uniform, and more dependent on stable conditions to sustain its remaining complexity. Nutrient cycling accelerated along herd routes, enriching some zones through dung while starving others through repeated depletion, creating mosaics that redistributed fertility unevenly and changed where life could flourish. Water systems carried the imprint of repeated use, with banks worn down, sediment increased, and floodplains altered in ways that changed how rivers moved through valleys. These effects did not vanish when herds passed, because the land remembers through structure, and structure outlasts presence. The giants thrived when the world was generous enough to keep paying the cost of their feeding. But the very act of thriving narrowed generosity by consuming recovery time, compacting soil, and making ecosystems live perpetually on the edge of rebuilding. This is the quiet paradox of gigantism, because the more successful the strategy becomes, the more it pressures the system that made it possible, and the more fragile that success grows across long stretches of time. The longnecks forced the land into a constant negotiation, where growth and consumption could coexist only if climate remained cooperative and corridors remained open. When cooperation failed, through drought, shifting conditions, or accumulating strain, the system tightened, turning what had once been advantage into dependence. Size offered safety from predators and efficiency in feeding, but it also trapped animals inside an economy that required stable abundance, predictable water, and time for landscapes to heal between visits. When those conditions weakened, giants could still endure for a while. But endurance is not the same as renewal, and populations cannot persist indefinitely on survival alone. The land's lesson is written not in drama but in thresholds, showing that strategies can dominate for millions of years and still remain contingent on environmental forgiveness. The age of longnecks demonstrates that slowness can be power when the world is rich, and that power can become precarious when richness becomes conditional. In the end, the giants did not rule because they conquered the land, but because for a long time the land could afford them. And when the land could no longer afford the full cost, the balance shifted quietly, not as an instant collapse, but as a gradual narrowing, where the world that once supported extremes began to reward smaller, faster, more flexible lives. What size cost the world was not only vegetation and soil, but margin itself. The spare capacity ecosystems need to absorb bad years without breaking. The longnecks lived at the far edge of what land can sustain, proving that life can stretch itself into astonishing forms when conditions allow, and proving just as quietly that even the greatest bodies are ultimately bound by the patience of the ground beneath them. And when the last heavy steps finally faded from the corridors they had carved, the land did not celebrate or mourn, because it does not think in those terms. But it began the slow work of rebuilding margin again, returning to a world that could survive without needing to feed giants. Follow for the histories of Earth that were written without witnesses, where the greatest forces moved slowly, and the deepest changes happened so quietly that only time noticed.